actually that you're programming on. So
Yes, on
x86
ARM in
and
particular, yes.
ARM in particular.
The mental health of the open source maintainers is something that large corporations don't care or don't see, right? It's just like, oh, yeah, I'm just doing an open source report and so on.
Some of it is financial, but some of it, and people should definitely support open source financially all across the board. But some of it is also like spiritual on a basic human level. There's something that happens like with this image of FFmpeg and so much of the internet depending on it, where people almost like talk down to the folks who are carrying these projects forward and maintaining
in the
it.
security community. They certainly did. That was one of the things I think that argument came out is there was a portion of the security community like, no, these guys write crap code. They need to fix their crap code. I'm like, no. This is a guy's hobby project. You've have a security bot that's gone and found some AI generated stuff. That guy didn't write crap code. It's just an edge case to the 99.99999 percentile. He didn't think about because it's his hobby project decoding Star Wars games.
I get the hobby project aspect of it. It's just hard work and it's beautiful, and it's like the right approach there is to celebrate people for doing incredible work. It's just incredible that humans step up, not getting really paid at first or maybe ever, and then they're doing it out of the love of it. And we need to, like, human civilization runs on people like that. We need to celebrate them.
To give you an idea, I received death threats on Videoland, right? And
you mentioned that to me. Like, what is behind that?
So that must be 2009, 2010, right? Apple is moving from PowerPC to Core Duo. That's probably in 2006. And by 2009 or 2010, I decided that we are not going to do new versions of VLC for PowerPC. At that time, like VLC, we were close to the number 1.0 release. We were 4 of us, right? Like, just like, no, this is not possible. So I received a death threat with some powder in it, right? Remember, there was some anthrax threats at that time, right? And it was because I had taken the decision to not maintain the PowerPC port anymore. And of course, it wasn't anthrax. Of course, it was some type of flaw and so on. But I received that with a letter of like, you're a piece of shit. You should die. PowerPC forever and so on. And it was 2009 or 2010, right? I was young. I was just like, why? What did I do? Right?
Yeah, they can break your spirit. It's like, why?
My mother freaked out, right? We had to go to see the police and so on. And now, like, I'm going to say that I'm quite happy that this happened at that time. It forged me a lot, right? I can take a lot of hate on me. I'm okay with it, right?
It sucks that that's part of reality, because all the people that love VLC, all the people that love FFmpeg, like me, you know, I legitimately probably thousands of times in my life had a smile on my face because FFmpeg made me happy. Period. And how many times did I get a chance to say that? 0. Until I realized there's a Twitter account. And every once in a while I'm like messaging it.
One of the things I like on the Reddit meme about me, which I don't like this meme for a lot of reasons, and someone says, "Oh, JB is on Reddit," which I am, right? And I say hello, right? And then I got so many people who say, "Oh, thank you for VLC," and like I take pictures and then I share that to the Signal, to IRC. Yes, we use IRC on different.
I saw you, as a quick tangent, you mentioned IRC is like Slack for old people. So you still use IRC?
Of course.
Yeah, I have it on my phone as well.
Of course,
every day.
Works fine.
Wow, it works fine.
Works fine, yes.
You have to power with a crank.
No, but there's no
there's no
ads, there's no tracking, there's nothing. Like it's
the biggest issue, to be honest, right, compared to Slack, is that it doesn't have threads. Yes. That's annoying. It doesn't have emojis for reaction. Sometimes it would be nice.
V3 has.
Yes, V3, but no one does it, and you cannot edit your messages.
Yeah.
Right? And the rest, it works perfectly fine.
Wait, how do you communicate without emojis?
Well, that's why I said it's for old people.
Old people. All right.
And we do emojis with like the columns and dash and,
Yeah,
and
exactly.
parentheses, right?
Old school. So anyway, you communicate on IRC. What were you even talking about?
Yeah, we are talking about death threats
Yeah.
but having people thanking you, and sometimes
Yeah.
they got people who send me a message and mail, oh, thank you for VLC, and I always answer because I want to validate the fact that you need to thank the open source community.
Yeah, please, everybody listening to this, celebrate FFmpeg, celebrate VLC, celebrate all the incredible open source projects, Linux, everything. There's so many, and you know what? I mean, even outside of open source, just celebrate companies that create software that you use a lot and love.
Celebrate human endeavor. Celebrate the human effort to not just build something that's okay.
Yeah.
Build something that is damn good.
Yeah, this is important, right? Like, because as we said, right, we work for we do something very complex for the normal people. Like, we want our excellence in tech to be useful for everyone. Yep. And this is why, we work, right? This is why I wake up in the morning. It's because I want people to use our stuff because it's making everyone's life easier.
I want to solve hard problems. Work on something interesting. Work on some interesting technical challenges.
And we are engineers. We love to build things. But when I was young, like very early, I knew I wanted to be engineer. I wanted to do cars, right? Maybe at some point I will go back to cars, right? But this is like, we want to build things that are cool and useful, and they need to be challenging, right? Because you want your brain to turn on.
When did the two of you first fall in love with programming, with building, with engineering?
When is the first time you programmed, Kiran?
Microsoft QBasic. As I was on Windows 3.1 and Windows 95. Microsoft QBasic.
Wow. What'd you build?
Like a multiplication, just counting loops, like 10, 20, 30, 40.
Nice.
Then I thought I could do everything after that. I jumped from doing that to I want to create a football soccer video game, and I drew everything out. I was like, I want to do it, and I didn't quite grasp that actually. It's a massive piece of work to jump from basic and drawings and pictures to a video game. But there we go.
I think I did also basics and then Turbo Pascal when I was end of elementary school. But mostly the first time I actually did some serious programming was the first year of you call that middle school when you're 11. I lived in Italy for a year in Florence, and it was an amazing year. And like the math teacher told us to work in a programming language called Logo, where you had a turtle that was designing things on the screen, and you turn left and right. And in the end, we used that to do very complex programming, because of course you could do things. And this changed, like, as I knew I wanted to do things with computers and program.
I don't think we quite talked about X264 properly. We talked about David.
Yeah.
Can we return, backtrack a little bit to X264, this thing that powers basically all of the video on the internet? So can you tell me the story of X264? And Karen, you're actually a contributor to X264.
So X264 is a video encoder for the H264 video standard. It dominates internet video, but also other areas such as Blu-ray discs. And Blu-ray discs are interesting because the people that make them really want the highest quality. And there's some really cool high-end films that have been encoded, broadcasting, and all sorts of other areas. X264 was a big step change because it kind of happened at the right time as well. A lot of the development took place when HD video was coming out. Intel Core 2 and Nehalem CPUs were getting fast. You could do real-time video. But the most important thing was a key sort of focus on visual metrics. So industry and academia for 20 years before was obsessed with mathematical metrics, or what's known as peak signal to noise ratio. So mean squared error, logarithm of mean squared error. And that led to tons of issues because mean squared error leads to blurring, because you actually want to minimize, you want to add a little bit of error to everything to reduce the mean squared error, as opposed to having a big error. And that led to loads and loads of blurring. So, but hobbyists bucked that trend. It was for their own personal videos, mostly anime. So there were two things they did differently, and there's a big iterative feedback loop with the community. They did some stuff differently. Two big things: psychovisual rate distortion. So using block energy trying to compensate for human perception when making decisions.
So the psycho-visual distortion, that's the critical thing. That's the thing. I mean, it's kind of revolutionary. Like that we can like rethink. Don't make it like this kind of theoretic thing of compression. Make it all about
being pleasing visually to the eye.
Yeah. So compressing in a way that loses the least amount of information for the stuff that matters for us humans.
Yes, exactly. As opposed to what some parts of industry are still obsessed by this, which is mathematical numbers that don't look good in reality. And then adaptive quantization was the other big one, where it was biasing bits against complex areas and redistributing them to less complex areas like grass. Grass has some high frequencies, but it's less complex overall compared to more complicated things. And this came around by Parkjoy. So Parkjoy was really the canonical sample that was running around in the park.
This one.
Yeah, so this guy was really the So this was created by Swedish Television in the beginning of HD, and it was done on film, and it was no expense spared in terms of production quality, and it was given away for free. This is the sample really that sorts the men from the boys, in terms of it has so many challenges with the trees, with the water, with the grass, with the motion, with the... I don't think there's still been any public test sequence as good as that these days.
So for people who are just listening, we're looking at a bunch of humans running along a river. You have the reflection, a lot of really high information textures everywhere, the leaves and the lighting playing with the leaves and all of this.
You could show clearly that encoders with high PSNR
will
blur everything, and you could see actually I could turn on psychovisual stuff, I could turn off adaptive quantization, and it would just look so much better. But your metrics, and these metrics are at the time were considered so holy.
Yeah,
these are the holy metrics that are untouchable. PSNR is the most important thing.
Can you speak to how do you measure psychovisual stuff? Like how do you turn how pleasing a compression is for a human eye into a number? Is that even possible?
That's what Netflix have been trying to do with VMAF. They said they've used a machine learning model.
That's a more recent thing, but back in when X264 was being developed, that's by eye.
It was by eye. It was developers on their laptops. So it's not like even with big companies with professional screens or anything. And that was actually one of the goals, which was the developers at the time, Lauren Merritt in particular, I don't want to test this on a $30,000 screen. I want this to look good on someone's laptop at home.
Yeah, brilliant.
There is another sample which is a sample that is a Planet Earth Kila sample that I absolutely love, and you're going to see why.
Again,
right?
I love this.
It's a ton of birds, right, flying, and the more it goes, the more there are birds, and at the end, right, it's almost like you have millions of birds. It's the most complex thing ever to encode, right? And you're watching it on YouTube, and you see how bad the YouTube encoding is actually, right? And this is like phenomenal to optimize and get perfect quality in a constant bit rate. There was a lot of optimization, mostly by Lauren also on anime, right? For a long time, anime was very badly encoded because there was a ton of bending, right? And so you see those issues, and there was a ton of things. So X264 is like, and today it's still the reference to any encoder, new encoder, AV1, AV2, VVC, HVC, everyone compares to X264.
One of my favorite films, Cinema Paradiso, I know the engineer who created the Blu-ray, and he showed me the comparisons of X264 versus others, and it's completely different. And I think a bunch of guys in the Blu-ray world started using X264. I think the big one was Chris Henderson from Warner Brothers. He did the whole Fringe box set with that, so quite like a thing a person on the street actually watches and wants to look good. And so they kind of took a risk in their jobs doing that, because they're in a big company. That big company can buy whatever they want, and they said, no, I want to use this free and open source thing so that things look good for my customers and build the best. And to this day, I personally still try and avoid watching the most cinematic films on streaming services and buy the physical discs, because they look they look good without even having to buy an expensive TV. I think that's the key thing.
And X264 is yet another example of open source project. It was started by Laurent Aymar when he was at the École Centrale Paris, where VLC was born. And then you got a generation of people like Lauren, like Jason, like Mance, like so many.
Henrik from
Henrik,
Anton.
and this is Anton, and this is where the assembly thing that we use now on FFmpeg David and so on was born, right? So X264 is like amazing project with people who were really all over the world, and I think most of them never met each other.
But all of them, according to Kieran, or large percentage, love anime. There's several things I've never got into, and one of them is anime, and I need to.
I watch anime so much, especially at the time. Like at the time, it was like a lot of anime content doesn't exist commercially, right? We're before Crunchyroll, right? So what happens is usually people who love anime, who take some things, some DVDs in Japan and rip them because there is no commercial offering. And some of the people who are what we call fan subbers are basically translating themselves to make subtitles, right? And at that time, you download completely illegally. It was the only way to do that, right? And so all of that was handcrafted, and it fits the open source community, right? Because they needed tools to encode, to do fan subbing, right? One of the most amazing open source projects for subtitles is called AEG Sub, and it's a subtitle. It's done for anime, for South Asian and Japanese languages.
There are weird textures in anime that I don't think you get in real life content. I think that was a key one, which was optimizing these weird textures that you get because anime is not done in a normal fashion.
Yeah, the way you produce it is not, you mostly produce it like on screens, right? Since a bit of time, and you have all those gradients, right, in colors because they are very easy to produce digitally, very complex to produce in real life. And the subtitles also are very complex because you need to have often the Japanese, and then you need to have the diacritics, right? The what we call the ribi, right? Which is the hiragana and the katakana for the kanji. And then because of course so that you have the official subtitling, but you also need the English subtitles or the French subtitles because you want to learn that, right? And there is so many things crazy on subtitles, and we had like crazy samples on subtitles that we've seen all around. So this is an important part of the culture, but also because there was no official offering. There was no way of doing that.
Can you speak to the difference between H.264 and AV1 and then X264 and David? This is this big step. Can you help people understand, are some of the streaming sites moving more towards that direction of AV1?
Let's be honest. All of those codecs since MPEG 2 video are the same concepts. The same concept about inverse transform, about intra prediction, motion compensation, entropic coding. All of them. However, each generation gives you a bump between 25 and 50% more compression for the same quality. And so you had the MPEG 2, you had the DivX area, you have H.264, which was like changing, right? H.264 improved so much. And then you had more, right? You had HEVC, you had VP9 at the same time of HEVC. VP9 is a bit similar to HEVC in terms of quality compression, but it's royalty free because in multimedia there is ton of patents, and the licensing after H.264 became out of hand, right? And could cost hundreds of millions of dollars per year. So it made no sense. So Google did this VP9, and the Alliance for Open Media did this new codec called AV1. So you can imagine that AV1 saves between 40 and 60% less bandwidth than H.264 for the same quality, visual quality.
At a given bitrate.
At a given bitrate, right? So that's really like you increase the quality. Either you set the bitrate and you increase the quality, or you set the quality and you decrease your bitrate. But because now you move from SD to HD and HD to 4K and 4K to 4K HDR, like you increasing the size by like factor 2, 3, 4, right? So you need to have better compression to keep it in terms of something that is manageable.
It's more coding tools, more bigger blocks, lots more subpartitions in each block. It's just exponentially more complex.
It's more complex because the encoder needs to search more possibilities, right? So you, for example, one of the things that is easy to understand is to predict a block, a color block to another, you have directions, right? You can go left, right, bottom, up, and then in terms of like the other quadrants, right? That I call north, northeast, northwest, and so on, right? But that's 8 directions. Then you can do more direction. You can do 16 or 69 or 128, right? You can, and every time your encoder is going to spend more time to see, oh, well, these blocks is exactly this one, and those type of tools that you can bring. And the encoder needs to check which of the tools are going to compress you better. And so I guess that AV1 encoding is 2 order of magnitudes more than H.264 in terms of CPU cycle, right? Order of magnitudes, right?
Yeah. And as we discussed, CPUs are not getting faster. You're just throwing more cores at the problem.
But also, it's a fact that you encode once and you have hundreds of millions of users, right?
Yeah.
So, for example, YouTube, a very good example. YouTube encodes almost everything in H.264, but the popular video gets re-encoded in AV1 because it costs more, of course, to encode, but you encode once and you send that to millions, right? So it's a trade-off between encoding time and complexity and CPU usage on the server side and on the client side. Because at the end, if you're distributing a video to hundreds of thousands of people and the size is half of the other, then it's better. It's better for your battery, it's better for your modem, etc., etc.
So we can lay out, let's say, the top 5 codec container combos would be H.264 inside MP4 containers, AV1 inside MP4 WebM containers, ProRes for nonlinear editing inside MOV containers. So for people who don't know, I guess ProRes is...
It's Apple's codec for editing, originally for Final Cut Pro. And it's designed to be fast to decode, fast to seek, because an editor will need to move very quickly. So it's a different use case to the distribution element.
There's no or very minimal temporal compression.
There's none yet. There's none in ProRes. So you can cut. So you can do cuts.
This is what we call intra-only codecs, right? So I'm going to explain quickly what is IPB frames.
Yes, please.
So iframes, often keyframes, but is complete frames. It's like an image. It's a JPEG, right? You can start, you see everything, right? And then the next image can be a P frame, which is a predicted frame. So you take some part of the previous image saying, well, I need the block 5 and 7 and 42, and you replace it, and then you just give the extra information, right? But that means that in order to decode this P frame, you need to have access to the previous I frame, right? And then, of course, you have more complex ones, which are B frames, which are B predicted frames, which can be depend on different type of frames, some in the past, some in the future. And so ProRes is an intra-only codec. For the people who can see, this is a very good one, right? So iframes are complete frames. P frame basically depend only on iframe, and B frames can depend on in front.
In this GOP group of pictures, I think the default for actually FFmpeg for H.264 is like 250 frames, something like this.
Yes.
And to me, it's like magic. Like you could predict that you can have a complete frame every
several seconds. That means
several seconds, and then you could have this chain of predictions you make. And the fact that somebody like me can use FFmpeg to compress something and not notice that the result still plays back smoothly, it's like magic.
You can even have, and we use that in tons on Kyber, is what we call intra-refresh, where basically there is no iframes.
You have no iframe. You have one at the beginning, and you never send an iframe.
How does that work? What is
you build up an iframe gradually across as the stream continues. So
you refresh certain parts of the image.
But so you never have an iframe. Like this is intra-refresh that we use, right?
That's even
but for me, the biggest mind blown when I started was the B frames.
Yeah.
B frames means B predicted frames can depend on frames that are coming in the future.
Mm-hmm.
That means that in order to decode this B frame, you need to wait for the next frame that is dependent, buffer that, decode that one, so that you can decode the B frame, right? So the way you decode the frame, the decoding order, is not the same as the display order, right? That means the encoder needs to be very clever and decide that, well, I'm going to depend on things like in the future. So this is
incredible.
like mind-blowing.
Yeah.
The fact it works so smoothly every day is kind of miraculous in some ways. It works so you can have a stream that works across the world on their decoder versus one in the US versus one here of different manufacturers, and they produce bit for bit exactly the same material. That's quite remarkable, and do quite complex things, and getting more and more complex, and still be bit exact. There's a lot of work that goes into that.
There's a lot of knobs you can control in this whole process. There's a lot of really fascinating parameters that I've gotten to know more and more over the years that FFmpeg gives you complete access to. Maybe you can speak to some of them. So first of all, like obviously we can lower the resolution, we can lower the frame rate, we can use different kinds of codecs as we mentioned from H.264 to AV1. There's ways to tune the trade-off between bitrate and quality, as we've kind of spoken to. You could do constant bitrate, you can do constant quality, say RFCQ, QP. You can do the longer or shorter group of pictures, GOP, that we mentioned. I mean, all that kind of stuff. It's crazy. Number of B frames.
Yeah, what is crazy is that a ton of people's job is to optimize those parameters, right? A ton of people that you see at YouTube, at Netflix, at Meta, and so on, they're not writing codecs. They're just like finding the right parameters for the file they have, for the format they have, right? Because like something that is for a movie or something that is user-generated content from your phone or a screen recording or something that you're going to video edit, you don't want the same things. And there are thousands of people whose job is just to optimize all that.
Yeah, they're wizards. Hats off to them. YouTube, like to deliver all the streaming sites actually, to deliver at scale. And like YouTube is really magical because it's not just doing like what Netflix it does, which is one way, like broadcasting type thing. It's also has to upload videos from all the places. So they're also doing encoding at scale. For videos, they're going to be watched by like 5 people. And it still has to deliver them like at a moment's notice. No delay, nothing. Very minimal latency. And also serve it in all different resolutions. Like YouTube is basically the web version of VLC.
Well, actually, that's funny because like Google Video, which was something they did before they acquired YouTube, was actually using the VLC plugin so that you could run VLC inside the web browser using the ActiveX plugin. And so it worked in Internet Explorer, and you were actually running VLC inside your browser, which is funny because today we have the opposite, where we have VLC WebAssembly, where we compile all VLC and FFmpeg to decode, to run VLC inside the JavaScript virtual machine with WebAssembly.
Okay, there's this legendary story that you pointed me to, that it was discovered via WikiLeaks release of all 7 documents. The CIA was using a modified version of VLC to basically try and trick people, to steal their data?
Yes, exactly.
So can you explain what the heck happened?
So this was a surprise, right? Because at some point WikiLeaks mentioned some documents. There were a few ones with something related to Blu-rays and VLC, but the most interesting one was the CIA Vault 7, which, if I understand correctly, was the CIA had like a custom version of VLC where they had a specific plugin. Yeah, exactly. Like we had to write a press release on that.
Videoland wrote a press release saying the only safe source for getting VLC media player is the official Videoland website. I mean, I suppose that's a security vulnerability for basically any piece of open source software. Somebody can trick you
to download in a fake website or targeted advertisement, right? That was a targeted advertisement to watch a specific file you need to watch with this custom version of VLC. And it was the normal binaries of VLC, except they added one DLL. I think it was psapi.dll, which was basically reading your document folder, encrypting that, and sending that. And the thing is, this is very clever because once you're watching a movie, right, you're going to do that for 2 hours and you're not going to touch your computer. And sometimes it's normal because it's HD that your fans are going up and say, and there is a ton of CPU usage because you're using VLC, right? That's normal. But the thing is, what you don't see is that actually a powered version of VLCs that is used by CIA. We had exactly the same problem with Chinese hackers that were targeting Indian people, and that got VLC banned from India until I had to fight in courts in India, the Indian government, to unban VLC. They didn't use VLC, they took just one DLL because we signed the DLL correctly. And they used that DLL to do another program. So you had the VLC.exe and was calling libVLC, but it was calling it into a fake one, and they use that to target. There is not much we can do actually to block those type of hacks.
Yeah, and I think people should, for all open source software, for all software in general, people should pay attention where they download the thing.
Yes, because that means that they were not downloading it on websites.
Do the search engine?
No, they don't.
Just to clarify, because you can, to prevent threats from people manipulating SEO to get up there on the links.
Absolutely not, right? We have a big issue for like more than 10 years, is that there is a fake version of VLC in Germany that was reported now for 12 years, and Google basically decides not, they know what's in it, but the binary is too big for their virus analyzer to analyze it. And so, well, if you're in Germany, you can go to a website that is a fake version of VLC with a custom installer, and it's very popular in Germany because their website is in German, and Google mentioned that before VideoLAN. And the weirdest thing is that it doesn't do anything on your machine for 3 weeks, because that's how they do the detection. And after 3 weeks, there is a small program that is a service that's installed at the same time that wakes up after 3 weeks and starts downloading spyware and adware. And Google knows about it. They've decided not to do anything. The guys use dark SEO in Germany to do that at some point. And this is very damaging, right? Because one of the things that they're downloading is actually something that is replacing your ads inside your machine, right?
It's actually quite surprisingly effective, whoever is doing it with Twitter and X, with X. I'll get emails about your X account being hacked. However they phrase it, it gets me to like at least click on the email, not to follow the thing. And then you're like, man, whatever they're doing with the psychology to try to trick you, they're quite good.
There is a security version of VLC, right? You received an email saying, hey, there is a security version, update on VLC. Think about updating right now because it can hack your computer. You come, it's a website that looks decent, and you download it's a new version of VLC. Great, you don't know. A month later, you're hacked. You have no idea your button.
Yeah. So make sure wherever you're downloading stuff, it's legitimate. Part of the botnet. Speaking of which, so you've mentioned that VLC sandboxing is something you're working on, and it's actually something quite challenging. Why is it important? Why is it hard?
So VLC is a core with around 500 plugins, right? One of them is FFmpeg, but we support so many other formats. We support new protocols. We support new filters. We support weird architectures. And in this release of VLC, you have modules that are going to call your drivers, right? Mostly the hardware decoders, which are going to call your Intel, your NVIDIA, your AMD driver. Or calling FFmpeg, right? And there might be a security issue. There might be a security issue in the shader. There might be a security issue in VLC, in FFmpeg, that is going to basically crash. The issue is that you're running VLC like every other program, like Adobe, right? You're running it on your machine, and it has access to all your documents, right? So the idea is to be sure that you do a sandbox so that we can protect from ourselves. Because inside the VLC process is running some code that is not even ours, either it's open source for other projects that we integrate in VLC, or it's your GPU driver or something that is provided by someone else inside. And so when we crash, we want to not allow people to do bad things, right? Because one of the common way of hacking people is to crash the program, very often done with a web browser, very often done with PDF files, less often with multimedia, but that could happen. And when you crash, you launch something on the machine of the person. Could be a ransomware, could be a botnet, right? So security of desktop application is important. On mobile, it's a bit different because most of the mobile applications are running on inside their own sandbox. But for VLC, we could run it inside one sandbox. But the problem is that we need access to so many things that it's basically we would have all the permissions, right? And so if you have a sandbox and you put some holes everywhere, it defeats the purpose, right? So what we are trying to do, and we're actually doing, is splitting VLC into several processes. One is decoding, one is demuxing, one is filters, and all of them run into their own sandbox so that the whole VLC, a part of VLC crash, like Chrome crashes on some tab, right? It crashes a crash, but it did not crash the whole program. And this is what we're trying to do. And it's difficult because it's a sandbox that needs to sustain gigabits per second of mem copies. Now, it's not a website which is 5 megabytes or 10 megabytes. We're talking about hundreds of megabits per second. So this is why it is quite challenging. And this is a research topic that we are working on in order to have multimedia player that is secure.
This is all the kind of stuff you have to think about when millions of people are using. You mentioned something somewhere where like all the different features of VLC, when you have that many people using it, somebody will use every single feature and they will tell you about it.
Best feature in VLC is called the puzzle filter, right? So you click the puzzle filter and it transforms your video into a jigsaw puzzle, right? And
Nice.
You can click and move the pieces, right?
Yep.
It's very, very useful when you're watching a French movie, right? You're bored, because
yeah.
it's like very long things or a love triangle, right? We've seen that so many times, right? But you need to watch it because someone, your wife or told you to do that, or your boyfriend told you to do that, right? So you're doing that, right? And you can click and move the pieces around.
Yeah.
It's absolutely useless, right? Like, who cares about that? First, it was done by a math teacher in high school in south of France to teach his students about Bezier curves, which is something that everyone should know about, right? It's very useful. But the code was clean, so it got in VLC. It was merged in 2010. 5 years later, I received an email saying, "Hello, JB, I have a problem with VLC. The puzzle is too simple." And I was just like, what? And yes, the puzzle was in the UI maximized by 16 by 16, right? Only 256 pieces. And he says, "I'm sorry, but in a movie, I love puzzles. This is too simple," right? So there is a commit of me, you can check it online, which is JB changing that the dimensions are 256 by 256.
Brilliant.
My point is, so many use features are used by a few people, right? There is a way to watch VLC movies in common run without any UI, right?
Saw that you could do ASCII.
ASCII art. Is it useful? Very useful. Imagine you're debugging a multicast network, right? You have thousands very complex networking stack, right? You can SSH to all of the routers and put VLC on it with no UI, and you're going to see whether it's black or it's not black, right? So you see if it's all green or not all green, right? So you
Amazing.
can see. People don't realize there is so many things in VLC that are useful, and they have users, because once you have hundreds of millions of users, you have people who use every feature.
I would love to sort of zoom in and talk a little bit more about the distinction between kind of downloading a file and watching it offline versus streaming. So the complexities, the challenges of streaming. Is there something we could say about what it takes to stream files, because we've been talking about codecs, and I think a lot of that implies encoding and decoding without the having to communicate over the network.
Sure.
So can you elaborate, like, what's required to do over the network stuff?
Yeah, but it is less complex than it seems compared to everything that we've talked about. Especially because the most complex thing is not about streaming in terms of streaming services, but it was what was done to actually broadcast through satellites. Because in most of the modern broadcasting services, you can pause and you can go on. But when you're sending live streaming, whether it's broadcast or live for streaming services which are live, this is much more difficult because you need to encode in real time. When you go on a satellite, you have a specific size of the link, right? You cannot have a burst of bandwidth even for a second, right? Because you don't have the space for it in your total file. However, there is different types of challenges, which are interesting challenges, but I think they are less complex than the one we've seen with late 90s and early 2000s about broadcasting and streaming through satellite.
They're different. They're control systems challenges, whereas some are more mathematical. I think that's the difference.
In the streaming world, what you have is called what we call adaptive streaming, because the difficulty, and it's not really a video problem, it's mostly a CDN problem, is that you might have too many people watching the same thing at the same time, and it's a congestion of the network, right? So your player has difficulty downloading things fast enough to play them. So what happens is that locally, the player is going to read a lower resolution of it. But there are some very clever algorithms to do that, but most of it is quite basic, to be honest.
Even on the buffering side is pretty basic.
Yeah, you download a segment, what we call a segment, and then you time, right? And if it takes more than 50% of the time to download the segment, you go down to, right? And the difficulty is more about when do you go up in bandwidth, in quality. But this is not very complex to do. When you encode, you're going to encode 7 resolutions, right? And you're going to give the bitrate. The difficulty is to have your encoder give the same bitrate, but it's not as strict as it used to be. So
probably YouTube has to figure out how the human psychology side of that, like how pissed off do you get when it's like very low bit rate, and how long should it wait before it increases the bit rate even though the connection is better? Because maybe the changes in the bit rate is what like affects you psychologically.
I think actually the interesting one is the audio.
That's true.
You can kind of notice when they move from full fat AAC to there are compressed versions of AAC that use spectral band replication. You can kind of see it goes a bit tinny, and that up and down is very jarring. The video side is a lot smoother and there's less notice. It's really the audio. You can definitely feel it from when it's moved you from a different audio profile to one or the other. I don't know. We're surprisingly tolerant at skipping audio glitches. I'm surprised people I know who are not video engineers how tolerant they are to watching sports at 30 FPS, for example, whereas it should really be 60. The world is a lot more tolerant to that, but audio people are very. It's an immediate feedback mechanism of
if you hear a
changed.
glitch, you realize it directly.
Yeah, I get to fully realize that, I suppose. One of the things I'm afraid of when I listen to audio more and more, that I get to notice every single tiny detail, and that you can over obsess when people in general are able to kind of blur their consumption. They can look past certain imperfections.
But then when you combine like an event that is, for example, a sport event that is probably going through satellite or somewhere else and goes to a central place for encoding, and then you need to encode this older resolution in real time. You don't have time for QA. You need to push that to CDNs. You need to add probably DRM or protection. You need to have that over a ton of different devices. Then yes, it is complex, but and also like you're in the web browser or in very much different devices that you use for television, where you had like a defined set-top box or cable box that you know where you control end-to-end. So it's a challenge, but it's less. I think the networking part while you agree to have 10, 20 seconds of latency, I don't think this is very difficult.
Speaking of networking and latency, so your new effort, as we mentioned, is Kyber, which is aimed at ultra low latency. As you say, every millisecond counts, and you're applying that to remote control machines like robots, drones, computers. Can you tell me about it?
Sure. If you start from where we used to be, right? You used to use FFmpeg to encode files, right? And then we used FFmpeg and VLC to encode in streaming services, right? And then you need to go lower and lower. And the question was, where up to where we can we go? And this question is very important because there are many use cases where you need to be fast. And it's when you have feedback interaction, right? We are not just listening to something, you're actually controlling it, right? And that's the biggest difference that compared to what we've done so far is that I need video to have a feedback on something that is happening live, whether it's a drone flying, whether it's controlling a humanoid robot from distance, whether it's controlling a rover, whether it's playing a video game in the cloud gaming, because this is what I did on a previous job, right? I was CTO of a cloud gaming startup. And this is a very interesting topic because you push to the limit the network. You need to care not about the quality like we've done on video and we've talked about with X264. You care about latency because a millisecond is meaningful when you're controlling a car, right? Well, you've used Waymos, right? When Waymos don't work, and that happens even if 1% of the time, there is someone that is basically remote controlling that. And this is exactly the stuff that we're building. It's really an SDK platform to do end-to-end control of machines.
So this comes up quite a lot in a lot of different contexts in robotics. So obviously teleop is becoming more and more important, including for training robots via machine learning.
Yes, and what we do is a bit different from everyone else, is that we take only one socket, one connection, which is a quick protocol based on UDP, which is interesting because it's done for low latency. It doesn't have two of the, what we call the TCP end-of-line problem and the HTTP end-of-line problem. It's ciphered by default, but on the same wire, we send multiple streams, like multiple tracks. We send audio, we send video, but we also send the commands, right? Mouse, keyboard, gamepad, and so on. And we do that while maintaining coherence, right? Synchronization. Because what people don't realize is that all the clocks actually drift. And when you're controlling a robot is going to have like 2 cameras, 5 cameras, 10 cameras, a ton of captors, GPS, and so on. And if you want to train correctly your robotic AI model, you need to have all those that are in sync and currents. And what we've done, and it's all the stuff that we learn on VLC in broadcast in real time and MPEG-TS that Kieran's know well, is that we account for clock drifting. And so when I record a Kyber stream, a robot, I am sure that it's going to be predictive in the way you play it back. And so when you're going to do recording and training of your AI model, you need to be sure that every time you retrain based on the data is going to stay coherent. And clocks actually drift. Like the existing solution works with 1 camera. Once you're going to have 5 or 6, it's more complex.
So you want to make sure that the visual snapshot perfectly matches the time it actually happened.
Exactly. And also, if you're going to control, right, I do something on robot, I need to be sure that it is actually happening at that precise time, right? And so we have on the server, which would be a robot, a time of like re-time stamping mechanism accounting for clock drift for that, right? So that's one of the use case of Kyber to control robots. I also think like remote drones, whether it's defense or non-defense, remote cars, remote submarines. There is many places in industry or remote surgery where the expert cannot go everywhere the machine is because it's dangerous or it's too costly, right? So you allow people to have machines next to you, right? The goal of Kyber is to make distance disappear. because it's either projection of skills or projection of power, right? So imagine we are all like, you've seen the Meta Ray-Ban and everyone else, right? You need to stream there, right? Because you're not going to run anything over there, right? So you need GPU power that's on the cloud, on the phone to stream that. And so all of these use cases needs to be not about extremely low latency, but real-time latency for video. And so that means we're toying with the encoders so that the encoders encode a frame in 4 milliseconds. And Kiran, his company, also goes under those type of latency, because you need to optimize at max the local latency, right? Because it's the decoder, the encoder, and so on, because this time is going to be added to your networking time. And it's not just about low latency, it's also about like reliability. We do clever things like forward error correction, right? So forward error correction is you overtransmit a bit of data, right? A few percent. And while overtransmit, you're allowed to lose some packets, because all of that is very difficult over a internet network where you're going to do things very far away. And if you check that all packets are delivered, you add a ton of latency. If you don't want latency, what we do is that we overtransmit some data that you can reconstruct on the client side when there is things that are broken, right? So, and we a few weeks ago, we were doing the demo around Las Vegas for the CES. We had a rover that is fully 3D printed. It's very simple. It's a car, right? It's a small car with a telescopic arm, and it was actually controlled from France, right? And the video was with a webcam and a very small server, right? A small PCB was basically running and send that to someone that is on the other side of it. And so there is so many use cases. You can also think about having AI who are going to control many drones and so on. And technically, we need to be amazing in video. We need to be amazing at networking. We need to care about any milliseconds in networking, in encoding time, in decoding time, and also you need to integrate very low level.
So sync everything really well, but what kind of latency can you get to? Like, when you say milliseconds, what's the goal?
So my goal is 4 milliseconds glass-to-glass latency.
What's glass-to-glass mean?
So it's easy, right? You have a computer which is running a program, right? Probably a video game, and this one is actually running, right? It could be an example of a robot, right? And you have the replicate that is done through the network. And you want, if you take a 1000 hertz camera, you can take a picture and you want that to be at 4 milliseconds. 4 milliseconds means 240 hertz. Right?
Yeah, it's nuts.
So far, we achieve 7 milliseconds on the Windows to Windows or Windows to Mac. And if you look in the timing, there is around 3.5 milliseconds inside the NVIDIA hardware encoder and around 2 milliseconds on the Intel decoder, right? So like the encoder plus the decoder is already 6 milliseconds, right? So in order to go down, we'll need either to have some other type of codecs or some better encoder that are faster. But 4 milliseconds would be the graal.
It's pretty nuts. I love it though. I don't think anyone's ever achieved that, right? That's fast.
You can achieve that with custom hardware, with SDI, with professional hardware, but I want that to work over the internet. I want that to work with any robots where you're going to have a small Jetson Nano in or N150, right? I want that because there is going to be millions of robots, or drones are just rolling robots or flying robots or swimming robots, right? It's just a machine that you control. And in order, either you need to teleoperate them, or when everything will be fully autonomous, you need to teleobserve them, right? You need to check what's happening.
Yeah.
And in my view, in the future, like all those remote cars will be observed by an AI model, which is just going to say, well, everything is good. And when it's not good, say, hey, there is a problem. And then you have an operator, right? And this is going to be about safety, right? When you have your humanoid taking care of your grandma or my grandma, I want to be sure that everything goes well and I'm not in those type of horrible scenarios where the robot is dangerous. Or when I'm driving, I want like the car to stop when it should stop, and if needed, someone takes care of that, right? And so there is so many cases, scenarios about real time. And so the goal of Kyber is to make real time control of machine. Distance disappear.
It's incredible, and some of the same technology, some of the same ideas we've been talking about is connected to what you're doing.
And for me, it's amazingly challenging, right? Because I would say that on video I'm doing okay, but networking I have so much more to learn, right? It's about like congestion protocols, bitrate adaptation in real time, but it's quite funny. And so I created this project, and we have fundraised in the US, of course, but it's open source, right? This is important because we did not say that. Everything on Kyber is open source.
So how do you make money?
It's a dual license, commercial and AGPL, right? You remember what you said about licenses. Basically, if you want to use Kyber in your product, you must have your full product open source. If you want to use this amazing technology but not open source, you pay the commercial license, right? So the small people or the hobbyists and the very small guys who want to do that, they can use the technology. They build something that is open source and cool.
That's awesome.
And if you're a large company, you're going to have the support, all the IP, the right to modification, and so on. So yeah, it's really cool. And also I'm building robots, and I love that, right? Like the rover we have is 3D printed. We are finishing a demo where it's an actual wing, right? Like a type of drone wings that is also fully 3D printed. We are trying to do a sailboat that is 3D printed, and we'll work on some humanoids. Of course, they are not going to be very good robots, right? It's not our job, but we're here for everyone to make robots. Cool.
You're talking to the right guy. I love robots. There's a bunch of them upstairs. And teleop is going to be really, really important, especially as the number of robots scales across the world. So 100%. Let's talk about the future of multimedia. FFmpeg, VLC, but some of the codecs. We didn't really mention AV2. So can we just lay out what is AV2? What is the hope for it? What is H.265, H.266?
So AV1 is this codec that is done by the Alliance for Open Media, right? Where there is Google, Netflix, Amazon, Apple, Videolan, where we try to make a royalty-free, very good codec, right? And now it's being deployed. But actually, the codec was finished in 2018, but a codec takes years to be used.
Let's roll.
Hello.
Band us to bro, at least.
क्या हो रहा है भाई लाइक
I'm
I'm
tired of
tired of
fucking
fucking
playing Dust 2
playing Dust 2
again. I
again,
think.
I think.
अभी नहीं मार पाओगे भाई तो क्या लगा दिया 50 लगा दिया यार भाई हमें तो आपसे भाई कहाँ जाने की प्लानिंग -480 तो भाई मेरा तो जी खत्म हो गया भाई बड़ी बड़ी मुश्किल से प्रोसेस आगे बढ़ा है भाई अब जाके अब अभी आएंगे जून में एकदम से रिजेक्शन पट 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 अब तो मैं जर्मनी नहीं ला सकते ये देखो
Beaming
साल
through.
वेट कर
Until, until.
Bro, why is
Bro,
the
why is
fuck
the
not
fuck
taking a
taking a
screen, dude?
screen, dude?
देख ले चाइना चले जाओ ग्रोथ तो वहीं पे होती है भाई और कहीं नहीं होती है हमारे देश में ये जरूरत ही कब पड़ती होगी भाई All the
Well, low. Nice one.
सारी बची है अभी तो
Take
किसी
it,
का
take
नहीं
it, behind. Left side, left side, left side, left side.
कर रहा है भाई एक तो बुला ही लेगा भाई आजा आजा करके फिर तो वहां जाके भी तो भाई गंदगी मचानी है हाँ हाँ वहां जाके किसी को बस वो करता भाई प्रेग्नेंट हो गया था
Big glass. Tagged one.
भाई मैंने मेरा ये रेड रूम तो पीछे है मेन है भाई मेन
Ram.
मार लो भाई बहुत ही है तो भैंस से ये छोटी रैंक के बंदे ऐसे मारते कैसे हैं तो भाई बॉलर लग रहे हैं सीएस गो चलता था जब हैकर नहीं थे सीरियस कौन हैकर था तो सीबीएसई वेबसाइट आएगा देख सीबीएसई वेबसाइट आएगा मेरा तो भाई इंडीड आ गया
That's special.
अरे वो जो भी कर रही है भाई हो गया ये तो मोटी करते हैं इंजन था क्या
Dude, फायदा नहीं
मोटे की जवाब लग गया इसलिए मोटा पूछा है
हाँ चलो Green, any info?
No B. No one B. On B.
Okay, I went to
Okay, okay. B. Okay.
Did you guys find off? Oh, what the fuck? Might be saving off.
हाँ
Did you guys need it?
Started my journey as a web developer in internet. फिर भी रोके तो किसने आई मतलब वो पास हो गया था क्या वो राउंड क्लियर हो गया था क्या तो फिर उन्होंने वहां से बुलाया
Yes, sir.
आप गए तो थे भाई जैन आप किसका इंटरव्यू देने गए थे आप क्या था क्वेश्चन बंदे पूछे मतलब उन्होंने वहां बुलाया था पर आप गए आप तब आपने कहा कि खतरनाक क्वेश्चन पूछ रहे हैं मतलब पूछा जा रहा था जो
He was there, bro. Oh, fuck. Fuck. Right, let's go. HP.
Impression ही देता है लेकिन
Hey, hot shot, bro. What are you doing? और 11 पे गया bro. Mid low. Fuck. Too short. Just one bullet. 2 aim in. 2 aim in. One. Last 2 A. Last 2 A. Last 2 A. A. Fuck. Dude. This is a 11K guy. Ah.
ऐसे मार रहा है भाई, कुछ भी मार रहा है, भागते हुए पट 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 लग जा रहा है। 2K के बंदे से मेरा खेलने का मन नहीं करता। क्या रैंक आ रही है। दूसरा सरल मारा भाई। मैं भेजता हूँ।
Let's roll.
और अबे मार ये साला अपडेट हो रहा है
भाई पी तो देखियो ट्रिपल ये देखियो ये क्या गया कौन भाई रुको भाई कौन तोड़ने गया भाई है स्कोर तोड़ने गया मैं तेरे लिए करा रहा था पीछे देखे
कौन सा है भाई सब क्या कह रहा है ये वही जो तो भाई पहले फुल स्टैक का वो था उसके बाद वो भी गिर गया
सारा हेडशॉट लग कैसे
किसकी कंपनी का भाई पर एक्सेल शीट बनाते हैं भाई दूसरा अपनी कंपनी में खुद वैकेंसी निकालिए खुद को जॉब दे
अरे यार नाइस शॉट
काश मैं अंबानी के घर पे पैदा हो गया होता।
क्या होता फिर?
कुछ नहीं होता है, एटलीस्ट खा पी रहा होता, मोटा होता। अरे भाई, बल्क तो अच्छा करता है भाई वो। इंटीला में 1 BHK होता भाई, सोचो भाई।
साले सोने का वो मिल रहा है तेरे को और तुझे 1 BHK चाहिए तभी है?
एक ही चाहिए होता है इंसान को रहने के लिए, कुछ करने के लिए।
क्या करेगा?
जो बैंगलोर में करते हैं लोग। हाँ हाँ हाँ। ये डिस्कॉर्ड क्यों
वो
नहीं आ रही?
वो तो तू दिल्ली में भी कर ही रहा है।
दिल्ली में इतना वो नहीं हो रहा ना, दिल्ली में ऐसे केस भी हो जाता है।
कोई केस नहीं कर रहा।
क्लब और कैफे, ओ माउंटेन, वाह यार लड़की तो अच्छी लग रही है। आज तो मैं पानी में तैरना सीखा भाई, 7 फीट में। फ्रॉग जंप मारना है, ऊपर आना है भाई, मजा आ गया।
अच्छा पूल गया था, मैं भी आज पूल गया था।
मैं तो रोज ही जाता हूँ।
बहुत थकान हो जाती है यार।
स्टिल।
तो बैडीज के लिए जाता है ना।
नहीं मैं तो थोड़ा, मैं सोचता हूँ मेरे एब्स नहीं आ रहे हैं, मतलब पेट का मेरा पूरा खाली हो गया, मोटा मोटा, तो मैं सोच रहा हूँ वो पतला हो जाएगा।
तो खाने पीने से ही होगा यार, नमक वमक सब लेकर करके ही खाना पड़ता है।
हेलो हेलो।
आ रही है आवाज सक्सेस?
हाँ आ रही है। डिस्कॉर्ड लैग कर रहा है क्या डिस्कॉर्ड?
नहीं नहीं।
बड़ी देर में कनेक्ट हुआ साला।
हेडचुक मुझे ऐसा क्यों लग रहा है सिर्फ 100 या 50 मिलने वाला है सामने वाली रैंक देख के, और हम चुदने वाले हैं, ऐसा भी लग रहा है मुझे। एक हाथ तो है
तो 50 तो नहीं मिलेगा। 150 तो मिलता ही है मेरे ख्याल से मिनिमम।
भाई 111 भी मिला है मेरे को।
अभी अच्छा हाँ 111 113 में मिलता
हालांकि 111 नहीं मिला था, उसमें -500 हुआ था।
है। कौन
वो
सा
भी
मैप लग
भाई,
रहा
माई के
है?
तुम्हारे पास वो भी भाई।
उनका भी उनके
वो
भी
भी भाई
4 मैप
मंडी
लॉबी
मंडी।
है।
वही भाई अड्डी वड्डी लगा दूंगा, माइक ऑन कर लो, नहीं बोलेगा
हो
भाई
ही
ये।
गया। अबे हॉट हॉटस्पॉट के तेरे रैंक तुझसे भी नीचे चले गए। पर्पल पहुंच गया था तू तो।
ये तो
भाई
5 के भी पहुंच जाएगा अभी कुछ दिनों में। मुझे डर लग रहा है।
मेरा यही होता है, मेरा लाइफ में कभी ऊपर जाता हूँ फिर एकदम से नीचे जाना शुरू।
भाई मैं भी तो 14,999 गया था, उसके बाद तो भाई 7,000 पहुंच गया था।
यानी कैसे
भाई
तीन
उसके
तीन
बाद तो
पाँच
गेम
के वाले
गेम
एडवांस।
बोलता है तुम हारो, तुम सही से हारो। ऐसा लगता है कि गेम को वो नहीं मिल रहा, किक नहीं मिल रही है। जीत रहे हैं तो।
121 प्लस हो रहा है, 550 माइनस हो रहा है।
मेरा 103 मिलेगा मुझे, और वरना मैं हारा तो फिर रैंक डाउन है।
चलो भाई मिड चलते हैं।
103 मिलेगा, सोच रहे हैं 103।
खाया खाया रेड खाया, खाया 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 खाया।
लाइब्रेरी
लाइब्रेरी आया है एक अपार्टमेंट में, ऐप में ऐप में
क्या
ऐप में।
कर आएगा।
भाई तुम 2 बंदे मेरे आगे थे, ठीक है, मैं तीसरे नंबर पे था तुम्हारे पीछे, वो उसने मेरे को मारा है एम करके साले कुत्ते ने। मिड में।
अबे वो गलत एम लगता है तो कहीं भी लग जाता ना यार।
अरे नहीं, उसने लिटरली एम करके मारा है वहाँ पे, एम करके, ऐसा नहीं कि स्पैम कर दिया उसने बिल्कुल ही।
जब किस्मत में लिखा होता है ना शॉर्ट, वो उसी को मिलता है।
भाई
तेरे नाम की गोली थी भाई वो।
भाई
रश आ सकता है मेरे ख्याल से मेरे पे।
मेरा 1 घंटा लग।
चला कोई तो चला।
कहाँ जा रही है आपकी गोली ऊपर? साइड है, साइड है, बालकनी है।
अरे भोसड़ी का।
बालकनी का
अरे भाई मार दिया उसने मुझे। ऊपर एक और है, ऊपर ऊपर है, अपार्ट से अपार्ट से अपार्ट।
बॉयलर
बॉयलर आ
आप
सकता है, नहीं वही है ऊपर ही है। ऊपर 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 ऊपर। पीपी वाइजन चला रहा था। बॉयलर आएगा। अरे जल गया।
क्या बताऊँ, ये आईबीएम का रेफरल देने के बाद भी आईफोन को कॉल लिया है आपकी तरफ से।
भाई मैं क्या करूंगा यार, हमारे में कोई एचआर है ही नहीं, सब ऑटोमेटेड है।
यार किस्मत ही नहीं है, मेरे को लग रहा है।
अब तुझे तो बाहर जाना है ना भाई।
तभी तो जर्मनी आने वाला था कुछ दिन पहले।
टाइम पास कर दिया ना।
अरे वाह तो साइट है साइट है।
साइड में
बॉम्ब है तेरे पास, ग्रीन ग्रीन बॉम्ब है, जा। अबे ग्रीन बॉम्ब में चले जा भाई।
कोने में कोने में कोने में।
वो भी बॉम्ब है तेरे पे।
जा रे।
बॉम्ब साइड पे कहाँ जा रहा है बॉम्ब? क्या
चूतिया बंदा है भाई, वहाँ पे खड़ा
अरे
हो गया
मुल्ला
है
है।
literally।
आई वांट टू से फहीम यू इज लव। मुल्ला है।
अल्लाह वशागल्ला ग्रीन ना।
एक क्रॉस कर गया बॉयलर साइड में और एक का पता नहीं। भी आ जाओ।
ओवरी भाई ने निकाल दिया।
सीटी आ रहा है।
ऑफ पड़ी है मेरी बॉडी पे।
कॉफिन साइड ही जाएगा। आपके जस्ट पीछे ऑफ है, ठीक है?
ऑफ पड़ी है मेरी इधर। मनोज ड्रॉप इधर ही मुझे। हाँ
इधर मत बताएगा।
इधर भाई इधर नीचे ही दिए मतलब।
इधर मत बताएगा।
मैं क्या ही बोलूं। क्या बोलते हैं उसको?
साइड बोल भाई, मैं पीछे भाग रहा था।
कोने में
एक ही होगा एक्चुअली।
एक इधर आया शॉट है।
मर गया वो अकेला है। लेफ्ट गया। एक और है पीछे। ले ले बॉम्ब ले ले। प्लांट भी ले ले।
बॉम्ब तो दूर है तो।
एक नोस्कोप हो जाए। चलो भी चलते हैं।
फाइंड आउट कौन है ये, पीछे नहीं देख रहा था।
पहला मर गया ना, मरा एक हो गया था।
पीछे आ जाओ। कौन है? प्लांट करो साइड अपनी लाइब्रेरी।
ऊपर था।
लाइब्रेरी पीछे है।
चला गया।
आ जाओ।
देख ले
ऊपर था, मैं वही तो कह रहा हूँ।
ऊपर भी था भाई।
ऊपर उस टाइम नहीं था, बाद में।
वही तो कहूँ, कोई तो मरा था
हेडशॉट पे कितना का डैमेज है भाई?
क्या
टेक9 की एक हेडशॉट पे कितने का डैमेज है?
होगा 70 का।
90 भाई बात।
हाँ।
कल रात नॉक्सविल भाई मुझे फोन क्यों कर रहे थे?
कल
हाँ,
उसके लिए वैलो के लिए।
मैं सो रहा था, मुझे एकदम सपना लगा सुबह कि मैंने फोन आया था। अब मैंने बोला मैं नहीं आ रहा, चलो भागो। मिडनाइट।
बम ले जा, चल बम ले जा, बम ले जा, बम ले जा, ले।
साइड
एक एफ भी तो खेलता है।
एक अंडर है वो। पिट निकला, पिट से बाहर निकला। हेलो, लाइब्रेरी है।
आखिरी का है लोकेशन। अब सेव कर रहा होगा, अब सेव कर रहा है, बनाना ही होगा।
बड़ा
अबे यार फ्लैश।
घुस जा ऊपर है घुस जा उस पे। छोड़ दे
आओ यार,
डिफ्यूज हो जाएगा ये पे, डिफ्यूज हो जाएगा। हो गया खत्म। छोड़ दे
साले
वैसे।
तूने मिट्टू ये बोला, तू मिट ही नहीं गया। क्या भोसड़े बंदे आते हैं भाई।
एक प्लेयर आ तो रहा है।
क्या हुआ?
वो होगा नहीं भाई।
वहीं खेल रहे हैं क्या? बी पे खाली एक बंदा आ रहा है, खाली वहां से सारे का सारे उधर ही खेल रहे हैं।
एक प्लेयर आ तो रहा है।
दो बंदे में मार दिया, रुका मत करो इतना दूर तक। तो हमारे साइड में पहुंच गया।
एक क्रॉस किया है बॉयलर पे। अरे अभी रुक जा, हॉटस्पॉट मत जा।
एक बालकनी था, वन बालकनी देख।
पक्का
हाँ फिट हो गया
एक और है क्लोज।
वगैरह। अरे यार
कोई नहीं आया।
ग्रीन तुम्हारे साथ जा ही नहीं रहा ना।
तेरी बहन के लोड़े मुल्ले तेरी माँ चोद दूंगा, माँ तो अलग जा रहा
कितने बंदे वहाँ पे?
है। एक ही था।
एक ही
नहीं
तो
था
बचा
मतलब किधर कोई था किधर?
लाइब्रेरी
वो
साइड।
अरे यार शॉर्ट था। एप से आके मार देगा मेरे को लगा। शॉर्ट था भाई। एप से आएगा, अगर आएगा तो आएगा या एप से या शॉर्ट से।
तूने बोला ही नहीं, उसको आवाज ही नहीं जा रही कुछ।
मैं बोल रहा हूँ
एप
ऊपर
एप 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 एप। फेक प्लांट, गिव अ फेक प्लांट, गिव अ फेक प्लांट एंड किल हिम।
अरे उसको फॉर्म तो उठा रहे थे
अरे उसे इंग्लिश नहीं आती होगी।
गिव अ फेक प्लांट एंड किल हिम।
चला के वो भी शॉर्ट से आ गया होगा।
अभी शॉर्ट आ रहा है। प्लांट प्लांट प्लांट।
क्या कर रहा है? पूरे गया सामने भी दो के तीन के वाले।
मैं बनाना देख रहा हूँ, पता नहीं बनाना है क्यों। पता भी छोड़ के चले जाऊंगा, ये साला सामने आ जाएगा, देख लेना। पक्का पक्का आ जाएगा साथ में, फिर नहीं आएगा, फिर पीछे चेक नहीं करेगा। आधे टाइम पे एफके खेल रहा है। पूछ ले तो पूछ ले, पूछ ले, पूछ ले।
अरे मादर चोट जाने नहीं होती। हो गया था वापस तो। पहले प्लान लेना बनाना।